exposed to technology every day. It is a prominent tool and will only advance as we advance in our civilization. So, when the first computer was built in 1938, no one knew the impact it was going to cause throughout the world. As we advance in our civilization, it is only evident that technology will it will cater to our technological needs. And the next big step is quantum computers. So this is a picture of a quantum computer. So I'm an ISOL major, so I want to go with the technology route with that. So technology has always interested me. So that means I always want to keep updated with computers and the advancements that come with it. So that means that I watch a lot of informational videos when it comes to computers. So that's why I was exposed to quantum computing, and it piqued my interest. So in this speech, I will talk about computers and the advancements that will come with it. So my main points will consist of looking at conventional computers, then looking at quantum computers, and lastly looking at the benefits that will come with quantum computers. So first, let's look at how conventional computers work. So computers work by memory and storage means. So that means that ones and zeros are combined together to do simple math. So that's an algorithm. So then that's processed by transistors, and transistors can be turned on and off by ones and zeros. So those ones and zeros can store numbers, characters, symbols, etc. So that's binary. So right here, it's the ones and zeros being strung together to create an A. So then with those numbers, they go through the logic gates, and those are a number of transistors that are connected together, and then those are stored in registers, and then they are converted to new patterns of bits. So then this can be compared to our brain processing addition, subtraction, etc. So with computers, as we advance, there is a thing called Moore's Law. So that says that transistors double every 2 years. So the switches that assist transistors, or as you might know, the microprocessors, are becoming smaller and more powerful. And that's beneficial for us now because that's what makes our computers faster. However, as they become smaller, they're starting to break the laws of physics. So right here, it shows the gates of the transistors, this is a human hair, so you can see how small they're getting. So they're breaking the laws of physics. Therefore, it's halting Moore's Law. So it says that there is a limit. So now that I've talked about conventional computers, now let's look at how quantum computers work. So quantum computers work by, it dives into quantum theory. Based on Oxford Dictionary, quantum theory is the theory of matter and energy based on the concept of quanta, especially quantum mechanics. So basically it looks at the atoms and the subatomic particles. So quantum computers, or conventional computers, use a lot of energy, and that's why they heat up. But with that energy, quantum computers can use it to their advantage. So when it comes to quantum computers, conventional computers use bits and components. So just to refresh your memory of what bits are, it's just the ones and zeros strung together, and how they store things. So quantum computers use quantum bits, or as are more commonly referred to as qubits. So what that means is that they're stored at the same time. With conventional computers, they're stored at different times, so that's what that's showing. So the ones and zeros are separate, but with that, it's stored at the same time. So that principle is called superposition. So some physicists compare them to a spinning coin simultaneously. So it's always in a head and tail state. So basically, what this means is that they can store and process more things simultaneously. So that means that we get an even more powerful computer. So now that I have looked at how quantum computers work, now let's look at the implications that will come with it. So this is just a quick timeline of quantum computing. So the implications that will come with quantum computers is that physicists will be able to perform physics simulations. So that means that we can advance our knowledge of physics and understand the universe better. However, to get a real functional quantum computer, we have to invest in automation for quantum computers. And also another thing is big companies like Google and NASA can use it for their benefits as well. So whether it's making it available for all of us. So now that I have looked at the benefits of quantum computers and the implications that will come with it, now let's bring it to a close. So in this speech, I talked about what conventional computers are, what quantum computers are, and the benefits of quantum computers. In this speech, I looked at the future of computers and the benefits. So the quantum computers are coming regardless. So who knows, maybe in a few years we'll know how the universe began.